Lesson 8.1, Solving Systems of Equations Graphically, is all about looking for the intersection between two graphs. So in 10C, you should have found the intersection between linear equations. Now, this is going to be the same kind of idea, but we're comparing quadratics to linears and quadratics to quadratics. So what can happen is you can have two solutions, like in the first case right here, where you have two intersection points. You can have one solution if there is one intersection point, and you can have no intersections if there's no solutions. And then quadratic, same idea. You can have, in this case right here, no solution where the quadratics don't touch at all. You can have one point of intersection where they touch once, and you can have 2 points of intersection. So can two parabolas that both open downward have no point of intersection? Yes. Well, if you have one wide parabola and one skinnier one, they can have no intersection. So it would look like this: one wide one skinny one. As long as they're kind of going at the same pace, they will have no intersection. One point could look like this, where you have a parabola downwards, and then you have another parabola over here, so they won't touch. 2 points is if you have one parabola, and then you have another skinny parabola kind of in between, so that would be a case where there is 2 points of intersection. Infinite would just be one parabola over top of the other parabola. So in this first case, example number 1, two divers start their dives at the same time. One diver jumps from a 1 meter springboard, so that's a diving board, and the other jumps from a 3 meter springboard. Their heights above the water are plotted over time. Which system could model this scenario? Explain your choice. So in this case, we know that one is jumping from a 1 meter springboard and the other is jumping from a 3 meter springboard. So we should see a change in the height, so it can't be system C. And we're starting at time equals 0, so that will also not work right here. And then what we should find is that system B doesn't work. The reason being is that if they start at different heights, they should reach the water at different times. So system A would be most likely to represent this scenario. So they have the 1 meter springboard versus the 3 meter springboard, and then the 1 meter springboard will reach the water faster than the person that's on the 3 meter springboard. So explain why there's no intersection. Well, there should be no intersection because they're at different diving board heights. Okay, so if you're at different heights, you're going to reach the water at a different time. Example number 2, they're asking us to do this equation graphically by solving, and we need to verify our solution. So whenever we solve graphically, we always want to make the equation equal to y. So what we're going to do is we're going to bring this y to the other side of the equation, and then in this case, when y is positive, you want to leave it on that side and bring everything else to the other side. So in the first case, we're going to have x plus 1 equals y, so that's one equation. The other one will be y equals, we're going to bring x squared over to become negative x squared, then positive 6x, and then minus 3 over. Okay, so that is what we're doing. Once you have them both equal to y, what you're going to do is you're going to put the x plus 1 into your y1 and your negative x squared plus 6x minus 3 into y2. So this will be y1, y2. So that's what you're going to start by doing in your graphing calculator. Okay, so start by putting x plus 1 in your calculator and negative x squared plus 6x minus 3 in your calculator. Once you have it graphed, what you want to do is change your window to the standard window for now. You want to graph it, and as you can see, there's two solutions because there are two intersections. So you want to find out that intersection and approximately that one. So you're going to press second trace number 5. You're going to go as close as possible to the intersection point, and you're going to press enter 3 times. Enter, enter, enter. And that will give you your first intersection, which is 1, 2. So we're going to write down the solution. So I'll write down the steps as well. So you're going to change your window. Your window is going to look like this. So you want to write down what you used for your window. We used -10 as your minimum, +10 as your max, and 1 as your scale. Why? We used -10 as your minimum, 10 as your max, and 1 as your scale. And then we press second trace number 5. We moved as close as we could to the intersection, and then we press enter 3 times. Okay, so we did that twice. So when you graph it, second trace, intersection, the first one we said was 1, 2. So you're going to write down the x and the y coordinate. And we have to find the second one by doing the exact same thing, second trace, number 5. Now you're going to move your cursor to the other intersection. So second trace, number 5, you're going to move your cursor as close as you can to that intersection and press enter again 3 times. So the other intersection is 4, 5. Okay, so once you have your answers, we can verify. So to verify, you can plug it into your left side and your right side to see if left side does equal right side. So for the first one, let's check 1, 2. Let's plug it into the first equation. X is 1, so we're going to go 1 minus your y, which is 2, plus 1. Does it equal 0? The left side is this, the right side is 0. 1 minus 2 is going to be -1, and then -1 plus 1 is 0. So left side equals right side, so yes, it does work. And then you're going to try 4, 5. You could plug it into the first one. You could plug it into the second one. So let's try it in the second one. X is 4, so 4 squared minus 6 times 4. So you're plugging in 4 for x. And then y is replaced with 5 plus 3. Does that equal 0? The left side is all this and the right side is 0. 16 minus 24 plus 5 plus 3 is 8. Well, 16 plus 8 is 24, and if you subtract 24, that will be 0. So both sides are equal, so that does work. So these are both solutions to the equation. So that's how you verify. You plug it into both equations, see if the sides are equal to each other. And we're going to repeat that for example number 3. So step 1, solve for y. So we're going to write y equals, we're going to bring the negative or the positive 2x squared to the other side, making it negative 2x squared. Then minus 16x, then minus 26. So that's our first equation. We can label as y1 if we want to. Our second one, we're going to bring that to the other side and the negative 19 to the left side. So we're going to switch their spots. So we know that y2 is equal to, and it doesn't matter which side you actually write it on as long as you do the proper switching of the signs. So it's going to be positive x squared plus 8x, and then when you bring over negative 19, it became positive 19. So once you have this written in, you're going to put that into your graphing calculator exactly how you see it. So it's all just about solving for y. We can't put it into our calculator unless we have y equals. So in our graphing calculator, clear whatever you have there, and let's enter in our equations. Okay, so again, I'm using the standard window, -10, +10, so my window still didn't change. But as you can see again, there are two intersection points. So I'm going to go second trace number 5, repeat the steps by going as close as possible to the first intersection as I can, and then press enter 3 times. So one solution will be -3 and 4. And then we have to find the other solution. Second trace number 5, enter, enter, enter. So our second solution is -5 and 4. Once you have your solutions, plug them back into the original equations to see if left side equals right side. So for example, the first one, 2, if we're plugging in -3 squared for x, and y is 4, does it equal -26? So you can use your calculator to help you. So we know that -3 squared is 9, so 9 times 2 plus 16 times -3 plus 4, it does equal -26. So left side does equal right side, so we know that this is a solution. And then -5 and 4, we could plug it into the first equation, the second equation, it really is up to you. So technically you wanted to plug each point into both equations to really confirm that it is a correct answer. But here, graphically, when you do find an intersection, they will be real answers. So the graphing calculator, when you graph it, doesn't give you any extraneous solutions. So in this case, we're seeing if we plug in -5 for x and 4 for y, does it equal -19? Yes, it does. So -19 equals -19. Left side equals right side. So this point works as well. So that is just verifying your solution. Example number 4, they're giving us again two equations, and they're asking us, we have a linear one, and then they're saying that it's going to curve with this quadratic one. So the quadratic one is modeled by this top part right here, which is -0.002x squared plus 5.4, as you guys can see. And then we have one equation that's linear, which is this part right here. This is the y equals 0.08x plus 6.2. And this one's the one that's going downwards. So y equals -0.075x plus 6.103125. Okay, so we know that there's 2 points of intersection, one there and there will be one there. So we're pretty much comparing the linear with the quadratics. So we need to find out the intersection points between them. So we're going to graph, if you want, all 3 equations on one graph. So you can plot all of these on one graph to save you some time. Okay. So clear whatever you have already in there, and you're gonna put in your linear one, your other linear one, and your quadratic. When you graph it, it should look like this right here. So what we want to find is the intersection between them. So just by looking at the colors, we know we're looking at the black in comparison to the other one. So the black, we're going to have to change our window slightly. So I'm going to change my window to go from -20 to +20, just to see if I can see an intersection there. So this will work. So I want to find this intersection right here with the blue and the black. So second trace number 5. Go as close as possible to it and press enter, enter, enter. So second trace number 5, enter, enter, enter. So sometimes it doesn't work with this calculator version that I have, I find. So I will try again. Okay, so there's my first one. So one set of coordinates would be this -19.37 and 4.65. Now let's answer the first question. Actually, it says they do want us to write the two systems of equations used to determine the coordinates of the beginning and the end of the curve. So the two systems, the first system is going to be where you have y1 equaling your first linear one, and your y2 would be the quadratic. And then your second system would be, again, the other linear. And your quadratic, same quadratic. Now it says use a graphing technology to show the surveyor's layout. So we already did that. And see, they just want the coordinates of each end of the vertical curve to the nearest hundredth. So our first coordinate, -19.37, comma, 4.65. So that's our first point. And now we want to solve for the second point, second trace number 5. Move your cursor to the red. Then I need to be on the black one. Enter, enter again. And your point should be 18.09. .75. So those are your two intersection points that they're looking for C. Example number 5, they want us to create the system that represents this scenario. So we actually need to write the equations of these two using what we've learned in the quadratic unit. Okay, so whenever we write an equation, we always need to write it in the form y equals a x minus p squared plus q. So what you'll notice is that the stretch is the same for both the green and the blue. Now you can always solve it to confirm, but once I find the a value, it's going to be identical for both. So let's start with the green one. The green one, we can see that the vertex, the P and Q, will be the coordinates of 0.75, comma, and the height is halfway between 4 and 5, so we can say 4.5. And so then we'll compare the blue one as well. So the blue one, the P and Q, will be 1.75, and our height will also be 4.5. Now we also need another coordinate. So for green, for my x and y point, I'm going to use the point that's the easiest, which would be 0, 0. And for my x and y for the blue graph, I'm going to use the point of 1 and 0. Okay, so that's what we're going to plug into both equations to get the system, and then we can solve for the solution, but it's actually pretty evident just by looking at this. So we can look at this graph to find out the system. So when it comes to y, we have 0 equals a, which is what we're trying to solve for. Our x is 0 minus our p is 0.75 squared plus our q is 4.5. So we're going to bring the 4.5 to the other side, making it negative 4.5a. And then we just have to put that squared into our calculator, 0 minus 0.75. So that would be negative 0.75 squared. So we know that that's 0.5625. Divide both sides by that number to get a by itself. So we're trying to get that stretch. And the a value is negative 8. Okay, so once we have this value right here, we know that it's going to be the same thing for the other graph as well. Okay, so with our equation, we do need to write it out as well. It should be negative 8 x minus p, so x minus 0.75 squared plus 4.5. So that's our first equation. This is the green one. Our blue one is going to be y equals also negative 8, but then the vertex is going to be different, so that's what changes where the location is. So it's going to be x minus, our p was 1.75 squared plus 4.5. So these answer question A for both. Now what you can do is to confirm this, we can graph these by putting this into our calculator, one being x1 or y1 and the other one being y2. And then if we find that the intersection matches what we have in the picture above, that's how we know that we've done this. And that answers question C. And we will see if it makes sense as well, and we'll see what this actually represents. Okay, so once you graph these two images, you want to find the intersection of them by going second trace, number 5, going as close as possible to that intersection, pressing enter 3 times, and you should get 1.25, which makes sense. The intersection, so this is answering question number B, is 1.25 comma 2.5. So that does look like that matches what we have right there. So that means we did the equations properly. And what this means is that at 1.25 seconds, the two performers will be at the same height. Okay, so that's what this is telling us right here. At 1.25 seconds, the two performers will be at the same height, and that is our lesson 8.1. Okay, so this is graphically being able to solve for that. Hope you guys